So you got an example of, well, that's something you can buy. Right? You can buy an Amazon, whatever. So let's look at some simple things. So this is a very, very simple thing. So this is, I actually built one of these with my 8-year-old daughter. It didn't look as nice as this, but you can do it. It's very simple. So basically, I have a piece of aluminum foil with reflects light in, and the material that you're cooking is inside there, and of course you close it so you can trap the liquid. Talk a little more about that. So the inner box enclosed in clear plastic or glass. Very simple construction. It's a reflector. This insulation, so this insulation is 40 quarters. You don't want to lose the heat. That's what thermodynamics comes into play. This is slow, even cooking because it's fairly big, uniform. It's very safe. You never got it too hot. Okay. It's a solar box cooker. You can also have what's called a panel cooker, which looks more complicated because we're trying to direct light, right, from more angles, a bigger aperture, we're collecting more of the sunlight. Right? So there's no inner box in this case, reflective panels. It's pretty simple. It's the least expensive. You can buy some just foldable panels that you can open up. However, something you may not think about, unstable and high wind, so if you're outside, you don't have a way to hold it down. Right? So it's something you need to think about. Doesn't retain heat, right? There's no insulation. So when cloudy. So you want something that could also work. Sometimes it depends on your market. So again, when you innovate, you also have to think on the other side. What is the problem you're solving, and who are you solving the problem for? Right? You have to think very, very carefully. So one of the important things in this class is that I want you to think from the technically, but also think from a business point of view. Who is going to use it, and let that drive the technology. Also, okay, it's very, very important. Parabolic cookers, probably the most complicated. You might have seen some of these, big parabolic dish. We'll talk more about why parabolas are perfect for this. Comes from non-imaging optics or non-geometrical optics. So it comes from the very simple geometrical principles we'll talk about later. You put something in the focus of the parabola, you can get very high temperatures very quickly. Cooks very quickly, needs sun tracking, but that means if the sun moves. Sun tracking is something we'll talk a lot about in this class, because that turns out to be a very big challenge. If the sun moves, how do you ensure that the focus remains on whatever you're cooking? Right? Not easy. So in this case, you have to mechanically move it. It's more complex, expensive, risk of fire, and break eye injury. So at this point, I want to take a minute or two. I'm going to turn on the light, and I want you to first introduce yourself to your neighbor if you don't know. I want you to think carefully about, I showed you 3 different types of cookers, and think among yourself, see how would you improve it? Just very basic. Simplest possible solar technology. How would you improve it? Okay, you should talk. I don't want you to be quiet and think in your own head.